All right, so today what we're going to do is we're going to begin section 3a using Pythagoras Theorem, which you will often hear me slip back into the way we say it in the States, and that's the Pythagorean Formula. Same gentleman who developed it, same information, it's just two different words for it. The theorem is actually just the idea that this works. But when you're using it, you're plugging things into a formula. So that's the reason one of them is a theorem and one of them is the formula. One of them is just the idea that it works, and then the other is you're actually using it. So I'm going to be using those interchangeably. I just want you to be aware of it, that they mean the same exact thing. So what we're going to be doing is we're going to be talking about finding missing sides of a right triangle. So just to refer back to and bring back your memory for a right triangle is a very specific type of triangle that has a right angle in it. Now that angle can be anywhere. It doesn't have to be oriented that way. It can be this way. It can be tall and thin. Doesn't make any difference. But in order to indicate that it is a right triangle, they're going to have to actually say in words that it's a right triangle, or they're going to use this little box in one of the corners. That box means that gives you one 90-degree angle. And the 90-degree angle makes a perfect corner. So it's the measure of the angle of a square. So that's why they put the little square inside. So these little squares simply indicate that this is a right triangle. There are things that you need to remember about a right triangle. We have two legs, and we label those A and B. And we have what's called the hypotenuse, which we always call C. Now the legs are interchangeable. It doesn't matter which one is which because they're both legs. But the hypotenuse is different, and so you must make sure that you get the right one for the hypotenuse. And there are two ways to recognize it. The hypotenuse is the longest side, and it's always the one that's across from the 90-degree angle. So it's really easy to recognize. It's always straight across from the 90-degree angle. So in this case, that's the hypotenuse. That is. It's that longest or the slanted side. The legs are straight lines. The hypotenuse is always the slanted side, right? So that's your first hurdle, is to make sure that you know which one is the hypotenuse. Because if you mix them up, the formula will not work. Okay? Now the other two sides, those straight lines, are just the legs. And it doesn't matter which one you call what. Traditionally, the shorter one is A and the longer one is B, but who cares, right? So we could call that A, that one B, this one A, that one B, this one A, that one B. It makes no difference at all when you're working with the formula, okay? Because they're both legs, so you can call either one you want to. Makes no difference at all. So the important one to get is the hypotenuse. That C has to be in the right spot every time, or else everything you do after that is garbage. Okay? So, now they can tell you that you're working with, they can tell you about the right angle or the 90-degree angle in lots of different ways. You could be talking about where the floor meets the wall. That should make a 90-degree angle, right? So they don't have to tell you it's 90 degrees, but they have to give you some indication that it is. You could have a flagpole sticking out of the ground. Well, where they meet, if the ground is perfectly flat, then that's going to make a right angle. Classic one is having a tree growing out of the ground, which you know from trees, they don't grow straight up, but that is an example of a 90-degree angle, right? So some of them you're going to just have to assume some perfect scenario to make it a 90-degree angle. Okay? All right. Again, which one is the one that you cannot mess up? C, the hypotenuse. It has to be the right one. The others, again, are interchangeable. All right. Once you've identified these, so the first step for working with these is always to label the sides. Okay? And we'll talk about steps in just a moment. Now let's talk about the formula. The formula is classic mathematics formula, a squared plus b squared equals c squared. And I know you've seen it before. What you have to remember about the formula is that both of the legs are on the same side, and this one has to be the hypotenuse. Okay? Again, it doesn't matter since you have a plus b and they're added together and they're both legs. It doesn't matter if you put which one you call which, but the hypotenuse must be in the correct spot. You also need to know that every term is squared. And squaring, of course, means that you multiply that number times itself. Okay? So not just the hypotenuse, but every single term squared individually. Do not do that. That does not mean the same thing at all. So make sure that you square each term individually. Okay? Right. So the formula is pretty straightforward. It'll be on your formula sheet, but you'll have memorized it if you don't already know it. Okay? So what we're going to do is talk about a series of steps for being able to identify and use any of these. Now you will have to remember how to solve an equation, but we've talked about that, so it's no big deal. So here are our steps. First step, label the triangle. I will be looking for a picture. If they don't give you a picture, you need to draw one. And you can just draw a picture of a triangle. You don't have to draw a tree in the ground or whatever. Just draw a right triangle. And you need to label it. And that includes putting the little symbol in, or the little square, to make sure that you indicate that it's a right triangle. Okay? So label the triangle. And remember that when you're labeling them, be careful about which piece is which. If you get the C in the wrong spot, then everything is garbage after that. Okay? Then, substitute the known values into the formula. They're not going to give you all of the values. If they gave you all three values, then there's nothing to find out. What we're using this formula for is to find the length of a missing side. Now, they can only have one missing side. You have to be able to have at least two of them in order to make this work. So you're going to put those known values into the formula. And I'm going to remind you that anytime you put a number in place of a letter, you need to use brackets. Now, these are distances, so they're never going to be negative. So if you don't use brackets, you'd be okay in this formula, but it's never a good idea. It's always a good idea to use good habits, have good habits on every problem. So use brackets when you're working with these. Next, you're simply going to solve, I don't really want to write simply, you're going to solve the equation. And solving these equations, you're going to see there's a pattern to it, right? And you're going to see that the book does it slightly differently, and there is something of a shortcut because you're all going to use your calculators, but it's really not that much of a shortcut. It's only because it only works sometimes, so you need to be careful about when you're solving the equation. Remember, the first thing you do is get rid of the brackets. And you know they're there because you put them there. Then you make sure to get your number terms and your variable terms on the same side. So you're going to square. When you're doing your brackets, that means you're going to square each term, because that's what's going to be on the brackets is those exponents of 2. So squaring each term. Then variable on one side, numbers on the other, and you move them by doing the opposite. So if it's positive, you would subtract it. If it's negative, you would add it, right? And then finally, what we need to do is get rid of the remaining square. Because what's going to happen when you do that is you're going to end up with something like c squared equals 144 or something, right? So we still have to get rid of that square. So that's something we haven't done in any of the equations that we've looked at so far in this course. But to unsquare something, you simply take the square root of it, right? So the opposite of a square is a square root. Go ahead and take care of everything else you've done and do this part last. Just take the square root. And remember that whatever you do to one side, you have to do the same thing to the other. So you have to take the square root of both sides. Now, when you take the square root of a square, they simply eliminate each other. We're going to look at lots of examples. You're going to do lots of work on this today. Then they simply eliminate each other. But when you take the square root of a number, unless if it's a number, I used 144 here in the example, 144 is a perfect square. So the square root of 144 is simply 12. But most of the time when you take the square root of a number, it doesn't come out evenly. So you're going to have to round. So make sure that you pay attention to the rounding rules. If it says 2 decimal places, or depending on the units that you have, right, make sure that you pay close attention to your rounding rules, right? And then finally, step 4, of course, is answer the question. You found the length of the missing side, but you need to tell me what that means. The height of the tree is 42 feet, right? So make sure that you answer the question. You'll see that on the last exam, there wasn't so much of that. The age one had a little bit of a bit part where you had to answer. But this particular one, when you're dealing with geometric shapes, there are often, the answer to the question will often be part of the number of points available, right? So make sure you answer the question. The height of the tree is, the distance from the tree, or the height of the plane, or whatever it is. Make sure you answer the question, okay? And when you answer the question, use units, meters, whatever, okay? So it's pretty straightforward. I know that you've done this before. Now is just the chance that you have to make sure that you're doing it correctly. And part of the reason for this is you're going to be using these ratios and some trigonometry later, so make sure that if you've had any trouble with this in the past, then this is where we fix it. Right? So what I'm going to do is we're just going to go to the exercises. We're going to do a couple together just to show you what these look like, and then you're going to do some on your own. Okay? So we have our right triangle. We have some of the measure. We have some of the right triangle. Stop it. Because of the little square in the corner tells us this is a right angle, which means that the angle opposite that square is the what? The hypotenuse, which is always called C, which in this case, they've been very nice to you and they've labeled it C. So the first thing we want to do is we want to write out our formula. It's a squared plus what?
B squared.
B squared equals C squared. Don't forget it. So we're going to label the sides. These two, the known values, are both legs, so it doesn't matter which one you call which. So we'll just call this one A and this one B. The hypotenuse has to be C. And in this case, they've already called it C because it's our unknown value. Right? So all we're going to do is, now that we have the thing labeled, we're just going to plug those in. So my A value is 2.5, and I'm going to put it in brackets and square it. Plus, my B value is 4.2. I'm going to put it in brackets and square it. And I don't know my C, so it simply stays C, but of course it's squared as well. Okay. Now, hopefully you have your calculators, because I'm going to need some squared terms here. We're going to take 2.5. So first thing we're going to do is get rid of all those brackets. We know they're brackets because we put them there. 2.5 squared means 2.5 times 2.5, which is someone? 6 point what? 25. Thank you. Plus, now we're going to take 4.2 and square that. Someone?
17.64.
17.64. Okay. And that still equals c squared. We can't square that one because we don't know what c is. Now we'll simply combine our like terms. So 6.25 plus 17.64 is?
23.89.
And that equals our c squared. My variable c is on one side by itself. My numbers are all on one side, so I can finish solving it by unsquaring that c. And the opposite of squaring something is taking the square root. So what we'll do is we'll take the square root of both sides. Now on this side, it's easy because a square root and a square will simply eliminate each other. On this side, you'll just put square root of 2389, which should be in your calculator anyway. Just hit the square root key, and it gives you what? 4.89. And we want this rounded to one decimal place.
That is rounded.
Oh, yeah, but we need to round it to one decimal place in this particular one they asked us to. So that 9 is going to round that 8 up. So we get 4.9 centimeters is our hypotenuse. Now this one didn't start out as a word problem, so it's not like the height of the tree or whatever. It's just C, that side C is, so you don't have to write out anything in words. So C is 4.9, but you do need to include the centimeters because that was the units we were looking at. Right? So pretty straightforward. Okay. Now, in the book, what they'll do is they'll eliminate the squares early instead of squaring each term. I think that's a mistake. I think it's if it's what you're used to and you can do it, fine, but it's easier just to square things because what happens is later, every time you see a square, you think you can do that. And that only occurs when every term is squared. It's a special situation brought on by this formula. And you don't want a special case. You want one process that works for every problem, no matter what. Right? So that's my humble opinion. Okay, let's look at another one. That one's hypotenuse looking for. Let's look at C. We have our triangle. Sorry, let's pull it up a little higher. 26x and 10 are our sides. So we have 26 millimeters, 10 millimeters, and x millimeters for our right triangle. Hop over and do some paper. So first thing we need to do is we need to label it. So we're always first going to label the triangle. Here's our right angle. The angle across from it is always the hypotenuse. So we're going to call that one what? C. The others are legs, so it doesn't matter which one you call A, which one you call B. It makes no difference at all. You can call this one A, this one B, or you can reverse them. Literally makes no difference. So now we'll plug that into the formula. The formula is A squared plus B squared equals C squared. If we call that one our A, that means our A is our X is X. So X squared plus, if that one's our B is 10. So we'll take that and square it. And our C is 26. So we'll take that and square it. The most common mistake is not squaring every single term. So make sure you do that. Now what we'll do is solve the equation. The first thing we need to do is get rid of our brackets. So x squared is not in a bracket. 10 squared is 100 equals 26 squared. Somebody got 26 squared for me, please? Sorry? 676. Thank you. Right? So in this case, my x is not by itself after I square each term. So what I need to do is I need to get that x by itself by moving what number? The positive 100, and I move plus 100 by doing what? Minus 100 from both sides, which gives me x squared equals 576. Then the only thing that's left to do is get rid of the square. To unsquare something, I take the square root. So I'm just going to take the square to both sides. On this side, that's easy. Those two things are opposites, so that's just going to eliminate each other. And the square root of 576, rounded to one decimal place, please.
24.
Oh, it's
Just
perfect square anyway. All right? So x equals 24, and of course, we need our units. So 24 millimeters. Okay? One way you can always check yourself is that this side is longer than this side, so 24 is bigger than 10, and the hypotenuse is always the longer side. So if you got, say, 28 here, we know that couldn't be correct because the hypotenuse was 26. So the hypotenuse has to be the biggest number, and the other two will be bigger or smaller in relation to it. Okay? All right. Let's look at one where it's given to us in words. Here's a classic one. A ladder is rests against a brick wall. So what happens when you put the ladder against a wall? If that's the wall, and that's the ground, and that's the ladder, the ground and the wall supposedly meet at a 90-degree angle, and so that makes the ladder the hypotenuse. But in this case, make sure that you remember which piece is which. Because if you're dealing with a particular situation given as a picture like this with words, then they want you to answer the question. We may be looking for how high the point is on the wall where the ladder touches the wall. We may be looking for the length of the ladder. We may be looking for how far the ladder is away from the wall. So make sure you label everything and that your picture is really well done. So the point on the ground from the ladder to the wall is 1.5 meters. The ladder itself, the distance from the ground to where the ladder touches the wall is 3.5 meters. And so what we're looking for is the length of the ladder itself. Right? That's our only unknown. The ladder is the thing that's across from the right angle. So in other words, it's the hypotenuse. So we're going to label it C. We'll label A and B. Does it matter which one's which? Absolutely not. So A and B, who cares? But make sure you label them and make sure you label your drawing so that you know that B is the wall, etc. So we'll plug those in to the formula. A squared plus B squared equals C squared. Our A is 1.5. Square that. Plus our B is 3.5. We'll square that. And our C we don't know, so we'll just leave it as C. Of course, it's a square as well. Now it's just a matter of plugging those numbers into your calculator and adding them together. 1.5 squared is, someone please? Hopefully you all have your calculators. In a moment I'm going to be asking individuals to answer these questions. So,
2.25.
I'm sorry, what? 2.25? Plus 3.5 squared, please, is? 12.25. And that equals C squared. Now it's just a matter of adding those together. So that's 14.5 equals C squared. And then we need to eliminate the square by taking the square root of both sides. Over here, that's just going to leave you with C. And the square root of 14.5, correct one decimal place is? I'm sorry? 3.8. Okay. So now we know the value of that, but we need to answer the question. So the ladder is 3.8, and what are these meters? Meters long. Capital T. Right? So make sure that you answer the question completely. Okay. All right. So we're going to go back. We're going to do some of these exercises together. We're going to be working on 3A. And if you look at your list, it's 1, 2, 3, 4, and 5. What if I have a plane flying? The plane is above the ground, right? So the height of the plane would be a hypotenuse or a leg? A leg. The ground would also be a leg, and then some angle distance between them would be the hypotenuse. So think about if you have something coming out of the ground or flying above a balloon or something like that, then that's going to be one of the longest leg, okay? Not the hypotenuse. All right.